Hi, my name is James Webb. I'm a senior director at Pure Storage within the Portworx business unit. Welcome to my PlatformCon talk. How big is too big? In this session, we'll explore key considerations for architecting and scaling your container platform estates. Before we start, let me introduce myself a bit further. Prior to joining Pure Storage, I was the infrastructure lead for T-Mobile's on-premise container platform team. I'd like to share not just learnings from that experience, but also insights gained from customers and thought leaders in industry over the past few months. As we get started, I want to give you an idea of what this session will be about. It's not a technical deep dive. More, it's some talking points on how to think about scale. So, when it comes to Kubernetes scale, there's no one size fits all strategy. What works for a fintech isn't going to work for a global telecom, vice versa. Your context, your team, your workloads, your risk profile, that matters more than any benchmark. Every choice introduces trade offs. You might optimize for performance, but sacrifice resilience. You might simplify operations, but lose flexibility. There's no perfect cluster, only the right one for your current needs and constraints. And ultimately, the best architecture isn't the most impressive. It's the one your team can actually run confidently in production. That means fewer 2 a.m. pages, smoother upgrades, and the ability to recover quickly when things go sideways. That's what real scale looks like. I'd like to start by sharing our experience with Cloud Foundry at scale at T-Mobile. Speed to market for delivery of new features is critical in the wireless industry, and Cloud Foundry was a key part of T-Mobile's digital transformation initiative. Our goals were not just to speed up delivery and improve availability, but also to provide a much better developer experience, not just by providing a better framework, but also by relieving them from the burden of managing infrastructure. That was the platform team's job. The platform was a hit, and as we started to install larger and larger instances of Cloud Foundry, we started to notice some issues. In our busiest foundations, we could see that we were often dropping logs and metrics, and during peak load, our control plane would degrade. Another downside to our scale was that the platform upgrades would sometimes take more than 12 hours, which became an unacceptable risk to the business. We had found our scalability limits. The solution was to scale deployments of Cloud Foundry horizontally and cap how big any one deployment would be. To support this, we developed some robust management tooling. We also provide our customers with two foundations to land their applications in so that we could operate the platform in a blue green manner. We didn't know it yet, but we were building a powerful platform engineering practice and one we wanted to use to deploy our next big project, Kubernetes. So, when we went to deploy Kubernetes, we stepped back and wanted to look at how the technology changed how we were doing things. Kubernetes is incredibly powerful. It can run clusters with thousands of nodes and tens of thousands of pods. But just because it can doesn't mean you should push it that far. As you scale, pressure builds on the control plane. The API server and etcd start to feel the load, especially during high pod churn or deployment spikes. You'll also start to encounter edge conditions and rare bugs that just don't show up in smaller clusters. These can be hard to predict and even harder to diagnose. Storage and networking complexity grow with size too. You're dealing with more data movement, more service discovery, and more opportunities for latency or failure. Upgrades also get slower and riskier, especially if you need to drain hundreds or thousands of nodes. And as the cluster gets bigger, the blast radius of any incident gets wider. One mistake can impact dozens of teams. So, yes, Kubernetes can scale, but pushing the limit often exposes fragility, technically and organizationally. The real goal isn't to build the biggest cluster, it's to build the one your team can operate reliably. So now that you've decided to deploy Kubernetes, you need to decide and discover a few things. Before you decide how many clusters you need or how big they should be, it's important to understand the factors that shape these choices. These are foundational inputs to your architecture strategy. First, the service model. Are you giving teams full clusters or just namespaces in a shared one? Cluster as a service offers isolation, but it's much heavier to manage. Namespace as a service is more efficient, but requires strong policies and guardrails. Next, think about your workload types. Stateless apps are easier to scale and recover, but if you're also running stateful services like databases, that adds complexity to storage, scheduling, and upgrade planning. Your infrastructure environment plays a big role too. Are you in the cloud, on-prem, or hybrid? Each environment has different failure patterns, scaling constraints, and automation possibilities. Then there's fleet management. If you're going multi-cluster, you need the tooling to handle lifecycle management, upgrade, and drift detection. If not, you want to keep things simpler. You also need to understand your scalability targets. How many teams and workloads will share this platform? How quickly are you growing? Don't over-engineer for a hypothetical feature, but don't underbuild for obvious growth. Security is another core input. Are you dealing with compliance boundaries or high trust workloads? That will influence how much isolation and policy enforcement you need at the cluster level. And of course, network and storage topology. Do your services require high east-west throughput? Do you need low latency or high durability storage? These physical realities will shape your failure domains and your scaling strategy. These are the kind of questions that will help you move from a theoretical architecture to something your team can actually build and run with confidence. So if you've done your research, you'll learn that the control plane is often cited as where most bottlenecks begin at scale. Let's talk about it. The good news is control plane stability has improved significantly over the past few years. For most teams, it's no longer the primary bottleneck at moderate cluster sizes. Kubernetes itself has gotten a lot smarter. Improvements in schedule performance, API server efficiency, and controller scalability have helped mitigate many of the early pain points enterprises hit. But there's still one part that needs close attention: etcd. Etcd is the heartbeat of your cluster. If it's unhealthy, everything slows down or fails. That's why you have to do the regular maintenance tasks to make sure that it stays healthy. You also need to watch all your performance metrics, whether it's for etcd or for the API server. Keep an eye on signals that may indicate things are starting to slip. And lastly, make sure you do your backup and restore testing. This is critical and often overlooked. So we really glossed over the control plane there, but it really isn't the bottleneck that it used to be. Let's talk about fault domains. One of the biggest architectural levers you have in Kubernetes is the cluster itself. The cluster just isn't a unit of deployment, it defines your fault domain. In most architectures, cluster boundaries are your failure boundaries. If something takes out the control plane, storage layer, or network around the cluster, it's effectively down, no matter how many replicas you're running inside of it. Kubernetes clusters are designed to be highly available, but that doesn't mean fault tolerant. A full cluster failure is rare, but it's absolutely possible. If you don't plan for it, it's going to hurt when it happens. This is why you need to explicitly plan for cluster level failures and not just the workloads inside of them. Backup and restore procedures, redeploying apps into another region, traffic rerouting, these need to be tested and not written down. Also, don't forget your external dependencies, things like cloud storage, DNS, or identity systems. If your cluster is resilient, but your DNS provider goes down, you're still down. So if you want real resilience, you have to think beyond the cluster. Deploy across multiple clusters, use global load balancing and traffic shifting to redirect traffic if one goes offline, and build systems that can recover quickly from failure. And once again, test your backups and recovery plans regularly. Don't assume they'll work when you need them. Confidence in your ability to recover is what turns a failure into a hiccup instead of a headline. Let's talk about upgrades, because this is one of the areas where a lot of enterprises are hitting the wall, especially those with that hundreds of deployed clusters. Kubernetes moves fast, 3 major releases a year, and staying current is critical. But in reality, most enterprises don't have the luxury of moving that fast. You've got blackout periods, tight change windows, and calendars full of business priorities that compete with platform maintenance. So even when the timing works out, the process is never simple. You need a well-defined promotion path from dev to test to prod. Each step takes time, validation, and coordination. And usually when you're done, a new release is out and it's time to start again. Change control is also a bear. Upgrading Kubernetes just isn't a platform decision. It touches workloads, dependencies, and often dozens of teams. Getting everyone aligned is its own challenge. The complexity only grows when you factor in things like API deprecations and validating third-party components, your ingress controllers, operators, monitoring agents. Everything has to be compatible before you move. Multi-tenant clusters. That makes things even harder. One version bump can impact an entire org, so approvals take longer and the stakes feel higher. Also, there's no real jump upgrade path, at least not natively. You're often stuck doing one version at a time, which slows things down even more. To navigate all this, some teams are trying new approaches, blue-green clusters, where you stand up a new cluster, move all your workloads over, and then cut over. Another uses backup and restore. You back up a cluster, you delete that cluster, you rebuild it at a newer version, and then you restore. Also, workload mobility is becoming more and more of a thing. So applications can move laterally between clusters. So essentially, you can evacuate a cluster, upgrade it, and then bring workloads back. All in all, upgrades aren't glamorous, but they're where platforms succeed or fail over time. Making them predictable and repeatable is one of the most important things you can do for your team. All right, so having said all that, what are enterprises actually doing for cluster scale? What we found is that most enterprises are deploying moderately sized multi-tenant clusters and some single-tenant clusters when needed, whether that be for specialized hardware, regulatory or security reasons, or some other requirement. Some shops have more homogeneous workloads that will deploy larger scale clusters, but that seems to be the exception rather than the rule. So, what is a moderately sized cluster? If you're building on VMs, it seems to be anywhere from 20 to 120 worker nodes. Some go a little higher. On bare metal, the high water mark is usually between 40 and 50. So, now that we've covered the scale, how are enterprises managing failure domains? The most standard pattern seems to be deploy multiple clusters into discrete infrastructure zones and then provide guidance to their application teams to deploy into at least two sites. This leads to the standard near far pattern shown here. In some cases, there may be a preferred location for an application stack to run, and you'll see the near far pattern shown here. In this instance, usually the far site is a business continuity or disaster recovery location. Platform teams are providing the clusters. Application teams are expected to manage the availability across sites. So if you haven't noticed the recurring theme, it's about operations. So really, the most important decisions you can make are about designing for day two. Day two is where scale gets real. It's easy to focus on getting a platform up and running, but the real test is how well it holds up once it's live and supporting actual users. That's when the real work begins. Customer engagement, incident response, governance, and of course, upgrades. These aren't one time events, they're recurring responsibilities that define whether your platform is stable or fragile. It's easy to build a cluster in the sprint, but operating it reliably, predictably, and under pressure, that's what really matters. Building takes weeks, operating lasts for years. So your design choices need to reflect that. Can your team support this cluster at 2 a.m. during an outage? Can they upgrade it without disruption? Can they troubleshoot it when things go sideways? That's why it's important to scope blast radius and keep failures contained. Simplify ownership so it's always clear who's responsible, and automate recovery whenever you can, because no one wants to write YAML in a crisis. Ultimately, the goal isn't just deployment, it's sustainable operations. A platform your team can run confidently, not just today, but months and years from now. That's what's important. So, before we wrap things up, I want to talk about where the ecosystem is heading, because new patterns are emerging that are reshaping how we think about scale and tenancy. Virtual clusters. Virtual clusters are gaining momentum. They offer stronger tenant isolation by giving each team or workload its own control plane without the overhead of full physical cluster. That also means version flexibility. You can upgrade one virtual cluster without impacting the others. And with dynamic provisioning, you can scale them up and out as needed. We're also seeing a resurgence in bare metal, especially as enterprises look for alternatives to VMware. This shift is focusing a realignment of roles and responsibilities between the platform, network, and infrastructure teams. Also, with bare metal, pod density becomes critical. You're running closer to the hardware, which means more performance, but also more complexity. You're going to be running more pods per node than you have before, and that's really something to take a look at. Finally, there's KubeVirt, bringing VMs and containers together under the same Kubernetes control plane. It's a powerful model for modernization, but it's not without its trade-offs. Operational complexity, performance overhead, and questions around the ecosystem maturity are all real factors. All that points to one thing. The future of Kubernetes is not one size fits all. It's going to be modular, multi-environment, and more flexible than ever, but only if you build it with awareness of these trade-offs. Okay, to wrap this up, I want to leave you with a few final thoughts. Things we've learned the hard way and that continue to shape how we approach scale. First, every enterprise is different. Your architecture should reflect your teams, your workloads, and your real-world constraints, not someone else's case study or benchmark. Also, you're not alone. Engage with the community and your peers. Some of the best insights come from hearing what didn't work for someone else before you repeat it. Focus on building a platform your team can actually operate. It doesn't matter how slick the demo is if your team dreads every upgrade or incident. Design for failure, not perfection. Something will go wrong. The best platforms recover quickly and minimize impact when they do. Also, keep in mind what works today may not work in 6 months. Business needs shift. Teams grow. Compliance rules change. Build with flexibility in mind. And above all, simplicity scales better than anything, especially at 2 a.m. during an outage. Avoid cleverness when clarity will do. At the end of the day, the right solution is the one your team can run with confidence. That's what real platform maturity looks like. And thank you for listening to my talk. Please reach out to me if you have any questions. I've really enjoyed it. Thank you.